Hey everyone, this is Guru. So I work in a company called Waku, and this is my colleague Sasha. So we'll be running you through Waku, and we'll be handling this session where we'll be talking about uncompromising Web3 communication at scale. So Waku is built on top of libp2p. It's a family of robust censorship-resistant communication protocols designed to enable privacy-centric Web3 applications. So the six values highlighted in the bottom are the things that make Waku stand off. The first one being privacy. So all the messages in the Waku network are anonymous and are completely private. And the second one is censorship resistant. So no centralized stakeholder can make any kind of censorship on any content in the Waku network. And it's also modular, which means Waku is not a blockchain, but it can complement any blockchain that you build it along with. And it's adaptive for different bandwidth limitations and resource restricted environments, and securely scalable. It's also spam resistant, and my friend Sasha will be adding more points about it in the coming slides. So quick history about Waku. In 2013, when the Ethereum white paper was released, the holy trinity of decentralized web was formed, where Ethereum was meant to be for the consensus, and Swarm for storage, and Whisper for messaging, generalized messaging. And until 2019, there were no dedicated teams building on top of Whisper, and it was a very slow progress with Whisper and Web3 communications as a whole. And in 2020, Waku V1 replaced Whisper in the Status app, which is one of the well-known Web3 communications app. And today, Waku has evolved as a standard for Web3 communication. When I say standard, it depends on the ecosystem that we've built around. So it's all these projects where we have Status with over 500K downloads on the App Store and Play Store, and Railgun, which is a privacy layer built on top of Ethereum, the Graph, which is also a well-known project, and XMTP, which is very much particular to the messaging use case. But Waku is not just restricted to messaging, but overall communications in Web3. So some of the key features my friend will be highlighting about it.
Hello, I'm Sasha. So the key features that we want to highlight is the adaptivity of the network. And what we mean by that is that you can run it as in an environment as simple as browser, but also you can run it in a particular node on a server in your ceiling or in a data center. So it depends on what you want to use it for. Another thing that we were working on is rate limiting. This is a huge problem in decentralized, in peer-to-peer networks, and how we solved it is through rate limiting nullifiers. And this is a way for us to rate limit the data exchange in the network in a privacy-preserving manner, and works it in a way that whoever wants to participate in the network has to create a membership, define a membership on the contract in blockchain, and later on use this membership to create proofs on the messages, and as well as validate messages received. So another thing is that we have our own network, and people can participate it in an open and permissionless manner. And it's for you, it could be as easy as using 2 lines of code in JavaScript, or as easy as running a Docker image, depending on the use case. And all these features are supported by the protocols that we have built on top of libp2p protocols that we use. One of them is Relay. Relay essentially is a mirror implementation of the Gossip Sub libp2p protocol. So I guess everyone here is familiar with this one. And this is the backbone of the network. All messages go through the relay, and I cannot add anything to it. But to facilitate some light clients, we built some other protocols, which are light push and filter. And light clients, as I mentioned, it could be as a browser tab or simple like that, or things like that. So the protocols here are request response protocols, and one of them is to essentially send a message to the network. This is called light push, and filter is to subscribe to some full nodes that are running relay under the hood and receive all messages on the network on particular pub/sub topic. And we can subscribe to them and receive messages from them for some topics that we are interested in. Another protocol that we have is Store protocol. Store protocol could be considered still work in progress, but it works in a way that it perceives relayed messages, and it gives you ability to query nodes in the network for some messages exchanged in the past. Yeah, this is the protocol used for that. Another protocol that we don't mention here on the slides is that we have a peer exchange. We use the DNS discovery for the bootstrap nodes and discover the peers in the network. And we have our own protocol, which is peer exchange. This is used for querying nodes in the network for some amount of peers to which we can connect to. And this makes it a robust way for light clients to discover other peers. That's it. So, Gora?
Yeah, so getting started with Waku, you have two verticals. The first vertical being operating your own Waku node and contributing to the network. And the second vertical is building on top of Waku as a developer. So when we look at the first vertical for operating a Waku node, there's no incentivization for the overall Waku network at this point, but it's permissionless and open for anyone to participate. So you can run your own Waku node by using our nwaku library, which is a NIM implementation of Waku, and the Docker compose command, which will be available on our documentation, and also dap node, which is like the easiest way to spin up a Waku node. So the second vertical, we're building on top of Waku. You can use our Waku SDKs like JS Waku, which is a browser-based SDK for building client-side applications. So JS Waku mostly utilizes the light node, light push and filter protocols, which are light protocols. So we have nwaku, Golang, and also Rust bindings and C bindings available for developers for use. So the resources that we currently have up in action are the documentation website, which is at docs.waku.org, and also the GitHub has all our open source code available. You can also check out our example apps at examples.waku.org. We have a list of 4 or 5 examples that use Waku. Also to mention, Waku is a product of years of research and development. So you can check out our RFCs at rfc.wak.dev, which pretty much has all the research articles and specifications for each and every protocol. The possibilities and use cases with Waku are limitless. So it's not just about chat, like I mentioned earlier, but it's for generalized communications in Web3. So you can build gaming, marketplaces, decentralized state channels, or anything that requires machine-to-machine or machine-to-user communication. So we also have a community curated list of ideas at ideas.waku.org. So yeah, you can scan our QR code. We are also hosting a private dinner tomorrow for our co-contributors of Waku and Logos Collective, and we'd love to host you all if you are available tomorrow. We'll be sending more information about our dinner on the Discord channel. Perfect. So I also have a few co-contributors around here. So if there are any questions, 1 or 2 questions, we'll be happy to answer them.
Any questions? Yeah, go ahead, Chad.
Yes, thank you for that presentation. Why is it that if I want to spin up a Waku node, I wouldn't use JS Waku as opposed to NIM Waku?
Cool. So one of the important aspects of Waku is to cater different resource-restricted environments. So JS Waku focuses more on light nodes, where we use light protocols like light push and filter. So the bandwidth requirements for these protocols are very less. So they can work in mobile phones or browsers and all these low resource devices. But when we talk about nwaku, it's mostly preferred for an environment with better resources, let's say. But they can also run in your desktops for sure. But then if you want to implement something within your browser, then we definitely recommend you to use JS Waku.